Section 7.5, operations with matrices. These are the objectives. There's two. You can pause to read and copy. I'm moving on to the next slide. This is the vocab and key concepts. You can pause, read, and copy. I'm moving on to the next slide. So find if possible. There's four parts to problem 1. You need to perform the following operations that you see above here, given that you have matrix A and matrix B, if possible. So here we go. Here's letter A. Are we going to be able to perform A plus B? And the answer is yes. Why? Because matrix A and B, they have the same order. This is a 2 by 2, and this is also a 2 by 2. How do I get this? All I need to do is I'm going to take this entry and perform this operation. I'm going to add those entries, and this is what you see here. In a little bit, I'm going to simplify this. And then I follow this entry and this entry, and I perform the sum, and that's how I end up with this. And you should be able to follow, how I get 2 plus 4 and 1 plus 2. Once I simplify, this is the answer to part A. Part B, now I'm going to need to perform, I'm going to need to perform the difference. I'm going to have to subtract instead of add. So you should follow how I get this quickly. Let me just go over the first one. So you're going to do 1 minus -3. That's why you see 1 plus 3. You should be able to follow the other entries, perform the operations that you see here. This is the answer to part B. Let's continue. Now let's go to C. I'm going to perform 3 times A. Now 3 is basically a scalar. So all I'm going to do is I'm going to take matrix A and I'm going to multiply by 3. Since I have 4 entries, each entry is going to be multiplied by this scalar, which is 3. I simplify, and this is the answer to letter C. D is now 3A minus 2B. I already know what 3A is, which is right here. So what I'm going to do is I'm going to perform negative 2B. So I'm going to multiply negative 2 times this matrix B. And this is what I get. So now what I'm going to do is I'm going to add these 2 matrices. When I do that, I simplify, and this is my answer. Let's move on to the next slide. Here's number 2. Again, same 4 parts as number 1. Different matrices, A and B. Notice that the order of this is 3 rows and 1 column. This is the order of this one is 1 row and 3 columns. So to perform letter A, the sum of A and B, since they are not the same order, not possible. To perform the subtraction, again, not possible. For letter C, 3 times matrix A, this is just a scalar, times matrix A, this one it is possible. Once I simplify, I end up with the following. I multiply each of these entries by 3. And letter D, again, this is not possible. Let's move on to the next slide. Says solve for x in the following equation. So you're looking at 2x equals negative x minus 4b, and you're given that matrix A is there, matrix B is there. First thing that I'm going to do is I'm going to work with the equation that you see there, and I'm going to solve for capital X. Once I do that, this is what I get. So now all I'm going to do is I'm going to perform the operations, these operations with matrix A and B. So I'm going to multiply matrix A by -1, multiply -2 times matrix B, and then perform the operation between them. Once I multiply the scalar, multiply this other scalar, this is what I get, and then I simplify those two matrices, and this is my answer. Let's move on to the next slide. This is number 4. It says find the product of A and B if possible. This is how you know it's going to be possible. This is how you should approach a product of two matrices. First thing, you want to find the order of each of the matrices and look at these two values. Since those are equal, the product is possible. Okay. Now you're also going to have to look at the other two values, which is the 3 and the 2, and this is basically going to be the order of the product of these two matrices. So the matrix is going to be a 3 by 2. How do I get the entries in this product? The way that you do, the way that you get the entries, this is what you're going to do. You're going to multiply this row times this column. And notice this is what I have. 0 times 2, negative 1 times 4, 2 times 1. Once you have this, simplify, you get negative 2. So this is your first entry. Then I go to the next one. I take still the first row, now the second column. That's why I get 0 times negative 1, negative 1 times negative 5, and 2 times 6. This is what you see here. I simplify the following and I end up with 17. So this is my entry here. Then I continue. Change the color here. So now I'm going to do this second row times this column. And I end up with that, which is 15. Now I'm going to go, let me erase these. I'm going to go with, again, still second row and second column. Once I simplify the product, I get, and simplify the product and the sum, I get 12. I go on to the last row times this column. Perform the operation here, I get 18. So this is my entry, and then the last one is going to be the last row times the second column. Perform the operations here, and I end up with 46. And notice that this is a 3 by 2 matrix. So this is how you perform the product of the two matrices, and this is the case where it is possible because these numbers match, and the order is the following. Let's move on to number 4. As you can see, the order is a 3 by 3 for both of them, and since these numbers match, then it is possible. Now what's the order? Is these numbers that you see here. So then I perform the operation, so I'm going to go row times column. I get 1. Again, I'm going to go first row times second column. I get 0. Still with the first row times the last column. Excuse me. Put in the entry there. It's equal to 0. Again, first row times the last column. I get this. I get 0. Then I go to my second row, first column. I get 0. Write the entry. Second row, second column. I get 1. Still with the second row, last column. I get 0. And you should be able to follow. This is my last row, first column. 0. Still with the last row, second column. Also 0. Bring in the entry. Bring over the entry. last row, last column, and I get 1. This matrix that you see here, this 3 by 3, or the product of A times B, is what we call the identity matrix. Ask me in class why we call the identity matrix, and it should make perfect sense why we call it this. Let's move on to number 6. Again, find the product of A and B, if possible. It is possible because these match, and the order of the matrix is going to be a 3 by 2. So perform the operations. So you're going to take first row, first column, first row, second column, second row, first column, second row, second column, last row, first column. I forgot to bring in the entry here. So this is the last row, first column. I get 1. Last row, last column. This is your answer to number 6. Next one. This is the last one. So now notice that the order is 1 by 3 and this is 3 by 1. Am I going to be able to perform A times B? The answer is yes, because these match, and the order of the answer is going to be 1 by 1, and that's how I end up with 33. So I multiply this row times this column, and I get 33. It's not 8, it's 7.5. Now I'm going to compute B times A. And notice that the order of B is 3 times 1, the order of A is 1 times 3. Since these numbers match, I can take the product. What is going to be the order? 3 by 3. So once I take the product, this is my answer. Again, I take this row, which is just 3, times this column, which is just 1. And then, so I get 3, 3 times 0, I get 0, 3 times 5, I get 15. And then I repeat the process. 7 times 1 is 7, 7 times 0 is 0, 7 times 5 is 35. And you should be able to see how I get the last row. And this is 7 3/4. Can we perform A times A? Let's look at the order. 1 times 3, and or 1 by 3, and 1 by 1. Excuse me. Do this. This is the order of the first matrix, 1 by 3. The order of the same matrix is 1 by 3. Since these numbers do not match, not possible. This concludes the video.